So the climate change first became of interest to the public in the 1930s. That is rapid global climate change. And it didn't come about through meteorologists or climatologists. It came about from Grandpa. Grandpa said, oh, you young people don't know what winter is really like. When I was a boy, the lake froze over in November and stayed frozen until the spring, and we had these horrible blizzards and so forth. The fact of the matter was that Grandpa was right. Gaffers who claim that winters were harder when they were boys are quite right. Weathermen have no doubt that the world, at least for the time being, is growing warmer. Because this was, they could take back statistics back to the 1880s. So for the first time, they were able to actually see, at least for the northern hemisphere, a kind of a global change. The thing was, meteorologists do not know whether the present warm trend is likely to last 20 years or 20,000 years. This is the idea, still very common today, that weather goes in cycles. It goes in short cycles, it goes in long cycles, it goes in sunspot cycles, it goes in whatever. The best known of these, of course, were the Ice Age cycles, and this was the great interest of the public and of climate scientists. The rewards would go to whoever could solve the riddle of the Ice Age cycles. Now, as I'll go through this pretty quickly because Mike McCracken already talked about that. Of course, the pioneer in this area was Svante Arrhenius. He was interested in winning the rewards of solving the puzzle of the Ice Ages. He looked at carbon dioxide because if, for some reason, volcanoes started putting out less carbon dioxide, then could we have an ice age? The answer was yes. Cutting the carbon dioxide level in half would lower global temperature by several degrees, and that was enough to cause an ice age. And along came his colleague, Arvid Hugbaum, and pointed out that the amount of carbon dioxide being put into the atmosphere exceeded the amount that was being processed through natural cycles. So Arrhenius went ahead and did the opposite calculation, and doubling the carbon dioxide level will raise global temperature by several degrees. This was something that at the current rate of emissions that was going on then, he thought would take millennia or perhaps as few as several centuries. At any rate, this was not something to worry about. It was a long way in the future, and in a popular work that was widely read, he pointed out that we may hope to enjoy ages with more equable and better climates, ages when the earth will bring forth much more abundant crops than at present. So even the idea of carbon dioxide fertilization as a benefit of the carbon dioxide was present at the time. Why so much optimism? Well, we must recall that at that time, a picture like this was not a picture of horrible pollution. This represented progress, industry, employment. So the general view was optimistic, but the general view, the general reaction to Arrhenius, as Mike McCracken said, was negative. There was this rather complicated question of the saturation, and then there were things that were easier to explain to the public. That the carbon dioxide at the rate that it was then being emitted would pretty much be absorbed by the ocean. It was not being emitted at a high rate by modern standards. And it was easily found that, the ocean is in equilibrium with the atmosphere, and so it'll all go into there because that's where most of the carbon is anyway. And then there was also, some people pointed out that, well, as the carbon dioxide goes up, the water vapor in the atmosphere will go up, we'll get more clouds, therefore there'll be more albedo, and therefore, again, it's a self-regulating system. And this was very much in tune with the feeling of the times that there's a balance of nature that regulates the amount of carbon dioxide in the atmosphere and regulates it in such a way to keep the Earth a fit habitation for life and for human beings. This began to come into question in the 1930s, partly because of droughts and dust storms that made climate change seem, the climate change that was perceived as going on through the warming that had been seen as being not necessarily benign, but something that should be looked into. And then, as Mike also mentioned, there was, of course, Guy Callender, who pointed out that the increase in temperature due to the artificial productivity of carbon dioxide is estimated to be, 0.3 of a degree C per century. Again, something that would happen in the distant future because the carbon dioxide level was not perceived as rising very rapidly. And he said that, well, that means the return of the deadly glaciers should be delayed indefinitely. Again, a primary concern with ice ages rather than with future deleterious consequences of global warming. Callender's theory did not make a very great impact. It was noted here and there in the press. He made some efforts to publicize it. But the general reaction was everyone has his own theory and each sounds good until the next lad comes along with his theory and knocks the others into smithereens. So the carbon dioxide theory of global warming was just one more theory among many others, sunspots, ocean currents, and so forth, just stood on the shelf with all the other bric-a-brac. The change came for Roger Revelle. Here's Revelle as a graduate student studying ocean chemistry. Revelle recognized that the ocean is not just salt water, it's a rather complex buffered solution in which ions like boron and so forth play a significant role. And he recognized that as a buffered solution, if you add carbon dioxide and make it more acidic, some of the carbon dioxide will evaporate back out again. This is the 10-year thing that Mike referred to. As Mike said, it took quite a while for climate scientists to figure out exactly what Revelle was getting at. It took a while for Revelle to figure out what he was getting at. But one contribution he made, which was quite significant, was that he pointed out that the rate of emission of carbon dioxide was increasing. This was a new idea in the 1950s. We're now taking for granted the exponential rise of industry and the exponential rise of the amount of the population, and therefore the doubly exponential rise of the amount of emissions. But this was a fairly new thing, and he pointed out that there was 4 times as much carbon dioxide going into the air as there had been in Arrhenius's time, and that this was going to double again by the early 21st century. So we have this famous statement that human beings are now carrying out a large-scale geophysical experiment, and Revelle made a substantial effort to publicize this. He talked about it to congressional committees, he talked about it to reporters, it got into the newspapers, in the sense that the science-attentive public, which was a very small fraction of the public, less than 10%, I suppose, could have become, if they were reading the, page 15 of the newspaper, could have become aware of global warming. By no means reached the public at large. Revelle himself, although he talked about, measurable changes by the 21st century, as in this report that Mike McCracken mentioned, this panel report that he mentioned. Although he talked about that, he wasn't really sure of it himself until it got measured that the carbon dioxide really was increasing. So he called on Dave Keeling. Keeling, in 1 year at South America, in Antarctica, managed to absorb. Let's see if this laser pointer works. Yeah, okay. So in 1 year, he saw, or 1 year and a half, he saw a measurable increase in the carbon dioxide, and this was the beginning of the Keeling curve, which of course has become iconic and is now inescapable in any discussion of global warming. So what was the reaction? There would seem to be every reason for producing as much carbon dioxide as we can manage that is helping us towards a warmer and drier world. Well, this wasn't everybody's reaction, and particularly as we get up towards the 1960s, even in the 1950s, there were the London killer smog. There was a lot of, there was a killer smog in Los Angeles. People were becoming aware of the dangers of pollution, and the idea of progress no longer seemed so attractive. Earth Day 1970, of course, captured this feeling that there was pollution, there was fallout from atomic bombs. We were messing up the atmosphere with chemicals, with fallout, and possibly with carbon dioxide. So the response of the scientific community now was to try to reach policymakers, and perhaps the public, but especially policymakers, by coming together with some kind of unified statement. And this was the beginning of this model of the invitation international meeting, of which the first one was a Stockholm conference held in 1971, the first study of man's impact on climate. And their conclusion was climate could shift dangerously, not benignly, but dangerously, in the next 100 years as a result of man's activities. And what did they call on policymakers to do? They called for a major international research program. They didn't call for any changes in energy policy, but they certainly did call for more research, which in fact was undertaken, and major international research programs began to get underway. Meanwhile, in the early 1970s, there were a very substantial number of climate disasters, droughts, starvation, literally starvation. And at the same time, the curve of the temperature had begun to decrease. There had begun a falling off, a cooling, which some scientists attributed, at least partially correctly, to aerosols. This was in the northern hemisphere, of course, where all the aerosols produced by industry were. And the primary exponent of this to the public, speaking on every occasion, was Reed Bryson, who spoke of the possibility of a new ice age. Now, he and other scientists were concerned about an ice age, but on this time scale of centuries, not within the next 20 years, but it was interpreted in the press as being something that could happen very rapidly. And Bryson himself came out with statements like there might be 1 billion people starving and so forth. He was quoted as saying this as a result of global cooling due to the increased particulate burden in the atmosphere. Bryson also said, I am probably the most misquoted climatologist in the United States. Whether it was warming or cooling that was in question, it was always the cutting edge and most extreme statements that the journalists picked up on. Steve Schneider was one of the just beginning to try to reach the public now. He himself was at first uncertain whether there would be warming or cooling, but whether it was warming or cooling, it could be dangerous, and he made considerable efforts to reach the public and tell them that climate science should be studied more carefully and that we should build more robust infrastructures to deal with the large changes that might be expected. Steve came under very substantial criticism from the scientific community, as did Carl Sagan for that matter. They were not expected to, they were expected to do research, not go out and make statements that might seem exaggerated or that could easily be exaggerated. His response was the 20-second spots on national television programs do not afford time for hedged statements. And if one is going to influence the public, one simply has to get into the media. In other words, shut up, you guys. Let me make my attention-grabbing statements, or otherwise we're not going to get any attention at all. Now, the response to this controversy over whether it would be warming or cooling was there was a fair number of reasonable journalists who caught on that all scientists agree that a new factor has entered the game of climate change, a wild card never there before, man himself. Except that all scientists didn't agree on that. Here's a very prominent meteorologist. The climatic system is so robust that man still has a long way to go before his influence becomes great enough to cause serious disruption. Once again, the balance of nature would take care of things. So the controversy was enough so that somebody took the trouble to write to 50 prominent climate experts and ask them what their predictions would be for the 21st century. Some of them worried about a slow cooling, a gradual descent over centuries into the next ice age. Some worried about a slow warming sometime in the 21st century, which seemed pretty far away in 1975. Most of them were not worried at all. All of them admitted that they were just guessing. I think this is important to emphasize when we talk about the warming-cooling controversy of the 1970s. It was entirely different from today when the scientists are pretty confident of what they know. So how did people become confident? Well, Manabe and Weatherald, or Manabe and his team in general, made a lot of good things, and I think one of the most influential, at least within the scientific community, was when he began to make real geographical models. And you see, I think you can make out North America and South America here. This is the real world. This is Manabe's world. And, well, he has some problem with the tropical rain bands, as do we all. But it's there. There is a tropical rain band there. And you can see the northwest is wet. The southwest is dry. It's not so bad. Yeah, 5 minutes? Okay. This did not make a great impact on the public, but it was certainly true that the climate was beginning to warm up again. Another thing that happened in the scientific community that was not so obvious to the public was that methane plus other trace gases add a greenhouse effect roughly the same amount as carbon dioxides. This has not yet, I think, been fully appreciated by the public, but it was appreciated by the scientists and resulted in this made a big impact in this VLOC meeting that Mike McCracken talked about. They said a rise of global mean temperature could occur, which is greater than any in man's history, and they called for more research, but they also called for a global convention and said that governments will need to change their policies. This was the first time that the scientific community, through, again, one of these international invitational meetings, called on policymakers to actually change their policies for the economy as a whole. Wally Broker, we must take our greenhouse experiment more seriously rather than treating it as a cocktail hour curiosity. We must view it as a threat to human beings and wildlife. Jim Hansen, of course, in 1988, famously, it's time to stop waffling and say that the evidence is pretty strong that the greenhouse is here. It's at this point in 1988 that the awareness of global warming went from less than 30% of the public to more than 90% of the public, just in the summer of 1988. Calvin, Hey Mom, wants us to hear about the greenhouse effect. The major news magazines, everybody carried stories about it. And that same summer, the Toronto Conference, a very major international invitational conference of scientists and some policymakers, concluded that to reduce CO2 emissions by approximately 20% of 1988 levels by the year 2005 should be accepted as an initial global goal. This was their call to policymakers. Well, they assumed that they had the trust of policymakers and the public, and other people understood that they did have the trust of policymakers and the public. So the Global Climate Coalition, a voice for business in the global warming debate, and other groups began to publish these very expert propaganda statements and pseudoscientific results. They had websites. They got support from people who were not supported by the oil industry, but just joined in. They got support, of course, from major media. And as a result, we had what seemed like a lot of scientific controversy. I think I'll skip over a couple of these things. I just want to point out, this is sort of scientific stuff. I just want to point out that the problem was, this is a wiring diagram of the climate system as had to be incorporated in climate models. And the problem was that there were all of these different scientific specialties that were involved in this, and each one of them had its own thing to say, and each one of them had its own problems with making themselves heard. And if you look at a wiring diagram of the scientific community, it looked like that. These are the scientific organizations. So the response, of course, was the Intergovernmental Panel on Climate Change, with its statement in 1995, the balance of evidence suggests that there is a discernible human influence on global climate. The most weasel-worded statement you will ever hear, a balance of evidence suggests discernible. It does say something, but it did not make a big impact on the public. What did make a big impact was their 2001 statement. Temperature is very likely to increase at a rate without precedent during at least the last 2,000 years. Also making an impression on the public was the actual rise in temperature. The hockey stick, which was a little hard to read, unfortunately, where the actual limits of the uncertainty were. This is a little better way of presenting it, which incorporates various things. However, people literally don't like to think or talk about the subject. Their concern translates into frustration rather than support of action. I'll skip through a couple of these things. This is all of the, a small sample of the academies that endorsed it, again, in an attempt to reach policymakers and the public. This is the results on Gallup polls. Very little change from the 1980s. And I'd just like to conclude by pointing out where the controversy now goes and where I think we should take it. We should take it into the political sphere. Governments spend $500 billion a year to subsidize the production and use of fossil fuels, a problem that I think all of us on left and right can agree on. It's not a scientific problem now, it's a political problem. And then I conclude my talks with a little bit of optimism. And finally, if you want 400,000 words and 2,000 references on the history, you can go to my website. Thank you. Were harder when they were boys are quite right. Weathermen have no doubt that the world, at least for the time being, is growing warmer. Because this was, they could take back statistics back to the 1880s. So for the first time, they were able to actually see, at least for the Northern Hemisphere, a kind of a global change. The thing was, meteorologists do not know whether the present warm trend is likely to last 20 years or 20,000 years. This is the idea, still very common today, that weather goes in cycles. It goes in short cycles, it goes in long cycles, it goes in sunspots. So the climate change first became of interest to the public in the 1930s. That is rapid global climate change. And it didn't come about through meteorologists or climatologists. It came about from Grandpa. Grandpa said, oh, you young people don't know what a winter is really like. When I was a boy, the lake froze over in November and stayed frozen until the spring, and you had these horrible blizzards and so forth. The fact of the matter was that Grandpa was right. gaffers who claimed that winters, the current rate of emissions that was going on then, he thought would take millennia or perhaps as few as several centuries. At any rate, this was not something to worry about. It was a long way in the future, and in a popular work that was widely read, he pointed out that we may hope to enjoy ages with more equable and better climates, ages when the earth will bring forth much more abundant crops than at present. So even the idea of carbon dioxide fertilization as a benefit of the carbon dioxide was present at the time. Why so much optimism? Well, we must recall that started putting out less carbon dioxide. Then could we have an ice age? The answer was yes, cutting the carbon dioxide level in half would lower global temperature by several degrees, and that was enough to cause an ice age. And along came his colleague, Arvid Hugbaum, and pointed out that the amount of carbon dioxide being put into the atmosphere exceeded the amount that was being processed through natural cycles. So Arrhenius went ahead and did the opposite calculation, and doubling the carbon dioxide level will raise global temperature by several degrees. This was something that at the cycles, it goes in whatever. The best known of these, of course, were the Ice Age cycles, and this was the great interest of the public and of climate scientists. The rewards would go to whoever could solve the riddle of the Ice Age cycles. Now, as I'll go through this pretty quickly because Mike McCracken already talked about that. Of course, the pioneer in this area was Svante Arrhenius. He was interested in winning the rewards of solving the puzzle of the ice ages. He looked at carbon dioxide because if, for some reason, volcanoes